You mean the recording? You still hearing it? Just now I pressed before you enter. Still can hear. So I think it's on like both ends. Yeah. Okay, let's see who's not. Wait, there are two more people. Okay, finish this one. Look at the answers. There's only one formula, WMG. M is WG, 350 divided by 2. In kg. What is the gravitational field strength of planet Y, planet Q? So the mass remain the same. So I write M equals to 145. Okay, same everywhere, the mass. So WMG, G is WM, equals 700 divided by 145. Okay, so why we don't take 350? This one, the weight, because 350 is the object's weight on planet P. So we take 700 because now it is on planet Q, right? So this is the weight on planet Q. That's why we take 700. We don't put 350 here. No. Equals 4.8 N/kg. Okay, one thing to remind you again. W equals mg, right? This one, if you are finding, let's say you are finding the g of y, okay, then you must take the weight at y to calculate this. The m doesn't matter because the m is always the same. If you want to find the g of planet P, then you must take the weight on planet P. The m is the same for this. So same, if you want to find the g of planet Q, then the weight on planet Q. Okay, so for example, this one B, the gravitational field strength of planet Y, right? So I find the g at Q, and the weight, I take the weight at Q, so 700. Okay, C, last one. Find the weight of a 650 gram on planet Y, Q. Keep messing up with this. Okay, so this is fixed. G, 4.8. We have M, 650. Again, what you need to do here? Change it. You're using N/kg. This one is G, doesn't match. Okay, 0.65 kg. W equals to 0.65 times 4.8. 3.12 Newton. Question number 2. Anybody got answer for this? Question 2, can do or not? What is the gravitational field strength of Jupiter? Okay, Daniel said 24. Any other different answers? Let's look at the solutions. Okay, so how do we find the G of Jupiter? Now, you are given the weight on Jupiter. So we got W equals to mg, G of Jupiter, weight on Jupiter. These two we got already, right? We got these two. But we don't know the m. Okay, to find the m, I use the Earth here. Earth weight is 55. Okay, W on Earth, 55 Newton. And we know that the G of the Earth is 10. Okay, find the m. W equals to mg. M is 55 divided by 10. So 5.5 kg. Now I get the mass, then I use Jupiter. Okay, W Jupiter, mass Jupiter. To find the G, W Jupiter divided by the mass. 132 divided by 5.5. 24 Newton/kg. Okay, next one. Next one, we look at pressure. Pressure. Okay, important points on pressure. Formula, we start with formula. P, here's a different color. Oops. P equals to force over area. How many units? Only one. This must be N, this must be M squared. So that gives the pressure Newton/meter. Or Pascal. Triangle. If you want to use this, then F on top, PA. Unit conversion. Okay, how many types of unit conversion you need in pressure calculation? So a few common ones like M square to cm square. What is M square to cm square? This one go here times 10,000. In the previous part, the density is meter cube, right? That's 1 million. This is 10,000. Two sets of zeros. 0, 0, 0, 0. Cm to m, divide 10,000. Sometimes if you are given like kilonewton, let's say 50 kilonewton, convert it to Newton. So 50 times 1000 equals to 50,000 Newton. Only then you put in the formula. Cannot put kilonewton in the formula. Okay, definition. What is pressure? It is the force. You see, F is on top of A. F divided by A means force per unit area. Force acting on 1 unit area. So like 1 meter square, here you have 1 meter, 1 meter. The amount of force pressing on this surface, 1 meter, 1 meter. That tells you the pressure. Okay, so these are the few things that you need to know. And then example, a force of 50 Newton is applied over an area of 4,000. Okay, simple calculation. What is the pressure acting on this area? Pressure, force over area, 50 and divided by, change this to meter square. So you divide 10,000, 0.4. $125. You can leave your answer in Newton meter square, or you can put it in Pascal. When an object of 20 kg is placed on the floor, it exerts a pressure of 80. What is the base area of the object? So it's asking for the area. We got the pressure 80. Where is the force? Change this to the weight. Okay, so you need to combine the weight in the previous chapter with the pressure. Okay, here I have to get the weight. So find the weight first. W equals to mg 20 times into 10. Assuming that it is on the earth, 10. So 20 times 10, 200 Newton. That's my weight, that's my force. So pressure, force over area. $80, 200 air. So area equals to 200 divided by 80. .5 meter square. When the force is applied over an area of 75,000, pressure is 60. Magnitude of the force. Okay, force equals to pressure times area. 60 into, this is in cm, change to meter square. Divide 10,000. 1, 2, 3, 4. 7.5. $450. What are the things that could affect pressure? Again, we look at factors affecting pressure. Okay, here you see a container. Suppose that it is half filled with water. We have the dimension of the container and the mass. So calculate the pressure acting on the floor. We get the base area first. What is the area of contact? It is the base of the container, right? So the base area would be 1 meter times into 0.5. Length times width. Okay, so 0.5, we get 0.5 meters square. Once we get the area, we get the weight. The weight is pressing on the floor. Mass given is 30 kg, so we do W equals to mg. 30 into 10. 300 of force is pressing. Pressure is 300 divided by 0.5. Okay, so we get 600 Pascal. What does this value tell me? 600 Pascal means what? If I change this unit, you see 600 Pascal is the same as 600 Newton/meter square, right? It means that when you take 1 meter square of surface, 1 meter, there is a total of 600 Newton of force is pressing on this 1 meter square surface. So if you take from the container, you take like one piece of it, and that's like 1 meter. That is 600 force. You add it up, everything, then you get the weight of the box. Okay. Now, how do I increase the pressure? What are the factors that could increase or decrease the pressure? So if we know that the pressure is the force over an area, okay, it is how the force is being distributed or how the force is spread over an area. Okay, so if you have a smaller area, then more force will be concentrated on that area. I repeat, larger area, the force is spread among the area, right? So you have less force on one unit area. If you have smaller base area, then all the force is going to concentrate on one single spot. That gives an increase in pressure. Meaning that if I make the container standing up, if I change the orientation like this, I make it standing up like this, the base area changes. Now my base area that is in contact with the floor is this one. Okay, what is the dimension then? This is 0.3. This is 0.5, the width. The length is 1 meter. Okay, then my new area would be 0.3 times 0.5. So area would become 0.15. Does the force change? Does the weight change? No, it's still half filled with water. Okay, maybe if you make it standing up, then it's like a quarter or somewhere here. Okay, half filled with water. Now, you see, area, if we find the pressure, force divided by area, what is the value of the new pressure? Force is the same, 300 divided by 0.15, we get 2000. From 600, it has increased to 2000. What have changed? The base area has changed. Does the weight change? No. The weight doesn't change. Only the base area has changed and the pressure increased. So we can conclude that same weight, small area. Okay, no, I'll put it this way. Same weight, decrease area, then I increase pressure. This is the first one. Is there any other method to increase the pressure without changing the object? Yes, I can add more water in without changing the orientation. Let's say now it is standing up. Without changing it, I add more water in. Okay, I make it full with water, fully filled with water. So I'm adding what? When I add water, then I'm adding the weight. So by adding weight and maintaining the base area, the pressure also change. So I can say that same area, increase weight, pressure increase. Okay, these two, very, very important relationship. So we can never look at one without another one. You always look at force and also the area. Force increase does not necessarily mean pressure increase. It depends on the area also. Provided if the area is fixed, is the same, then force increase, pressure increase. Correct, that is correct. That is the second relationship, this one, right? Okay, so what is the application of pressure in your daily lives? You see, during the rocket launch, when they want to move the rocket to the launch base, when they want to deploy the rocket to the launch base, how do they send the rocket? You see, the rocket is very, very heavy and it has a very small base area. It's like, looks like a cylinder, right? Or any missile, rocket, missile, or space shuttle, anything. Okay, they have small base area and they are very heavy. So because of the small base area and their mass, right? So they have high pressure. They will exert very high pressure on the base, on the ground. To minimize this pressure, what they do is they put it on a special vehicle, a special machine that has very, very huge platform, very wide platform, and the base is made of like track. They further increase the base area. What's this vehicle? They call it crawler. The crawler transporter is specifically used to transport the rocket to the launch base. Okay, why do you want to do this? Because they are trying to minimize the pressure, the weight from the rocket together with a larger base area. So the pressure acting on the ground will be small. It can be minimized. You can say like, you can think of it like this. The weight of the rocket is being spread over a larger area so that each unit now has less force acting on it. Okay, that is one application of pressure. Any sharp objects, they are made very sharp so that they can cut through easily. That is also application of pressure. Okay, so the mass and the area, remember that. Okay, exercise, next page. Okay, now you do this exercise, and I'll give you a few minutes. We look at the answers. Also, there's a typo here. This one changed to cuboid. Cuboid. This one, cuboid. Okay, all this changed to cuboid because I changed the diagram last minute. So I forgot to change the words. No, we don't add them. We don't add the weight. Finished? The base area. Okay, the cone base is circle, right? So what is the formula? Circle, pi r squared. How to find the base area? You see the hint given from the question. It says that the same amount of pressure is exerted by both objects, meaning that this pressure is the same as this pressure. The pressure exerted by the cuboid is the same as the pressure exerted by the cone. So what you need to do here, you can use the pressure that you get for the cuboid, use it for the cone, because they are the same, right? Area of cone, the base formula is pi r squared. We only take the base because that is the one that is in contact with the floor. Okay, so you're not taking the area of the entire solid, it's just the base. So the area pi r squared. The entire cone, if you want to take the entire cone, then there is a formula. Have you learned this in your mathematics? The geometry, I just want to know, like, have you guys entered the geometry chapters? The one that you learn about shapes and stuff? Not yet. Not fully. We are doing, or you're doing angles. You're doing angles. Okay. So the area, if you want to find the area of this thing, right? So this is pi r squared, right? This thing is pi rl. The length is the slant height. The slant height over here. Not the center height. It's the slant height. Okay. When you go to, when you doing the geometry, you will learn about this. Calculate the volume area of different shapes. Yeah, you will have a chapter on that in your mathematics. I think it's maybe in your pre-O2. Polygons. Polygon is not quite polygon is still angle. Polygon is still angle. This one is under the geometry, like surface area, volume, area, all this. Okay, we look at the answers in the next meeting. Send you one more link.